So last week we talked about the gas dryer and the burner on the gas dryer and how it operates. Today we're gonna do the gas stove, since a lot of you guys are in gas right now. Here's a schematic for a Frigidaire gas stove. It's just a simple basic stove. I wanna go over some of the components here. You see these arrows like this? Does anybody know what that symbol is? Yes.
Quick disconnect.
It's a quick disconnect, so it mainly means just like a plug between two wires connecting together somewhere in the machine. So if you see, we got them in different places. They call it a harness connector, but it is a quick disconnect for you to unplug and plug wires. It's not really a component that does anything in the machine. It's just, instead of wire nutting them together, whatever, they just plug the wires in. But if we look here, let's start off here with the oven circuit. Power comes in, goes through, goes to the thermostat. After it comes through the thermostat, it hits something called an oven igniter. And then it goes through the oven valve and out. Now, how are these three parts wired? Are they parallel or series?
Series.
They're all wired in series, okay? And it's very important you know that the oven igniter and the oven valve are wired in series for a couple of reasons. That the oven valve depends on the igniter to be functioning properly in order for it to let gas in the oven. So if the igniter is broken, gas won't come out, okay? The oven valve, the safety valve, does not get 120 volts even though it's on a 120 volt circuit. The igniter takes most of the power away, and we're going to do some testing on that, okay? So power comes in, the thermostat is the temperature control in the oven, and I have one of those here. This is the thermostat. It's just got two wires on it, and it's got this long capillary tube. Does anybody know what this is?
Sensor.
And what does it do?
To sense the temperature when it reach the level.
Yeah. How does it work? Does anybody know how this works?
Like convection, conduction, something like that.
No. Well, the reason why it's so long is there's a hole in the top of the stove. This goes down into the oven where you cook. If this is the thermostat, this is what you say, I'm going to bake at 350 degrees, for example. How does this switch, if it's up in the top, know how hot the oven is? So it has this sensing bulb here, and it goes inside the oven, and they're usually filled either with like a hydraulic oil type fluid or a gas. And when heated, that gas expands and pushes up through this capillary tube and pushes on a little, what they call bellows, and cycles a switch open or close. So when it gets hot, it opens up the switch. This switch opens, and so the igniter and the valve don't get power, the valve closes.
Yeah.
Okay? Now what happens? The oven shuts off, the temperature starts going down. When it gets below a certain level, this fluid flows back to the end of the capillary, and the switch closes again, starting the cycle over. Okay? So all this is when you turn it on, should be a closed switch. When it's at temperature, it's an open switch. There's nothing too complicated about this component.
Gotcha.
Now, let's take a look at the oven safety valve. Here's an exploded view of the oven safety valve, and let me see if I can pick this up here. This valve here is controlling the gas. This is the burner that's inside the oven, the bake burner, okay? And this valve here is what shoots the gas up into the burner. And if you can see on this side here, this is the igniter. All right? Now, how do we test this out? Let's take a look at the valve first. I have this as a blown up view of this because there's information on the valve that you need to be familiar with. So when you're testing it out, you need to know these numbers. And the two most important ones is this right here. What does VAC stand for?
That's the voltage is.
Voltage AC. And then what is that below there?
That's the amperage.
It's the amperage. Okay, so what happens on this safety valve, you can't really see it. There's actually two wire terminals here. They're just one behind the other. this valve only needs 3.03 to 3.3 volts of electrical current to open that valve. We call that a bimetal, which is two metals, and when current flows through it, it gets hot and it warps and opens the valve. When we turn it off, it cools down, it closes the valve. But the thing is we put the igniter here and two wires, and it goes like this, and this goes back to neutral and line one. And when you first turn it on, the igniter's cold. And when it starts to heat up, it draws more amperage trying to run and increases the amperage across the valve, which also puts more voltage at this point. So if you had an oven valve that's not lighting, for example, you go ahead and you turn it on, you checked the stove has gas. You turn it on and you see the igniter glowing. This is the igniter here. Mike, can you get that on the film? You see this igniter glowing here, okay? Once it reaches temperature, it's going to open the safety valve. I'm going to hook this up to power and show you guys it, but I'm going to show you how to test it. So what we're going to do is we're going to set this ammeter here. I don't know, Mike, if you can get the ammeter on the camera. I'll come closer. We got the ammeter here, and you guys want to come around and take a look at this. Can you see the needle?
There's a glare.
What if it's like that?
It's better.
Better? Okay. So you could check this with amperage or voltage. You put the ammeter here, or we put the voltmeter on the safety valve. Okay, I'm not going to do the voltage test right now, but we have to get how much amperage according here, 3.3 to 3.6 amps. If you look here, the highest setting on this ammeter is 6 amps. So we want to be just above 3 amps. If I have 3.3 amps or better, and the gas burner is not lighting, then you change the safety valve. If the igniter is glowing and you have only 3 volts or less, it's one of two things. Can anybody tell me what two things it could be? It is glowing, but I'm only getting 3 volts. What do you think it could be?
The safety valve.
Oh, it can't be the valve because I'm not getting the amperage across the valve. The igniter's bad.
Restriction, that igniter.
The igniter's, just because it's glowing. I remember when I first started working on these, the igniter's glowing. I said, oh, the igniter's glowing. I used to take my screwdriver and tap on the valve and the valve would light. Okay, your safety valve's sticking, the igniter's glowing, I'm going to get a safety valve. I go out to someone's house, put a new safety valve on it, doesn't work. And the problem is I really didn't learn to check the voltage and the amperage. I wasn't getting over 3 amps. I was getting just 3. And believe it or not, that 0.3 or 3.03 or whatever, 3.3 on this one, is that much of a difference that the valve won't open. So the igniter, even though it's glowing, doesn't mean the igniter's good. The other thing that could be bad, what if the customer is having a voltage problem at the house? The outlet or even the transformer to the house, they have low voltage. Instead of the stove having 120, they have 90 volts to the stove. Would the igniter still glow? Yes, but it's not enough voltage to pull that amperage. So if you have an amperage problem, one of the things you'd like to check is while it's on, check the voltage at the outlet and the wall to see if you got proper voltage. So I'm going to go ahead and turn this on so you guys can see this. Okay? And Junior, can you get the extension cord and plug this in for me, please? So in the second, you're going to start to see the igniter start to glow, and already the amperage is rising. It's at 1 amp, and it's slowly increasing now to 2 amps. And now we're just about 3 amps. Look how bright that thing's getting now. And we're about 3.3 to 3.4 amps on that. and the igniter's glowing, that means it's gonna be hot enough to light the gas. If I don't get that amperage there, and I'm down right on the 3 there, that valve will never open,
Nothing enough for it.
okay? So this is one way to test it, the other way is to check voltage on that valve. And we'll go ahead, I guess we can go ahead and do that next, let's do that. Unplug it, please. Okay, let it cool down a second. If you look here, this is how power's flowing through. I put a test cord on here. So power comes in, goes into the igniter, goes through the igniter, comes down to the safety valve, goes through the safety valve, and back out to the cord. So if I test this plug here, I'm gonna get how much voltage? 120 volts. Okay? But if I check the safety valve, when just like the amperage on the scale, it's going to start low and start to gradually increase the amperage as the igniter starts getting hot, and the voltage is also going to start to increase at this valve. So again, according to that sticker, it's 3.03 to 3.3. A lot of the valves on different manufacturers is very, very close to that number. But don't always go by your memory or whatever. Go by what it says. The valves have stickers on them, and they have that information there. The only thing that's going to get you is if it's so filled with grease and crap that you might not be able to read it on an old unit. But I'm going to go ahead and put this on 200 volts AC. Junior, I want you to hold these two right there in those two terminals right there for me while we're doing that test. I'll plug it in.
Careful.
So you ready? Okay, so I'm gonna plug it in. And if we watch, the voltage is climbing, but that's saying 2 volts, 2.9. How much are we supposed to have? 3.03, right? I haven't reached 3 yet. And that could also be the accuracy of this meter. But I only have 2.8 volts. And if I don't get to 3.03, it's not going to open. I'm gonna be honest with you. I bet you this meter's a cheap meter because I had the amperage. If I have the amperage, I should have what? The voltage. Because they work together. So this thing's not climbing up there. Went 2.9. I think it's just the accuracy of the meter. You can go ahead and take it off. That should be 3.03. If I had a better meter, these meters are cheap meters, then that won't work. So when you're in an oven, what you want to do though is when you have this, you notice how I had to have Junior hold it. You want to put alligator clips on your meter, clip your wires on here, and make sure you don't touch anything they're not supposed to, and that's how you're going to make this test. Remember, if the oven lights while your meter's down there, you don't want to have your meter so close to it that the flame's going to damage your meter. All right? Okay, guys, sit back down a little bit, please. A little bit blurry, but I just wanted you to see this. If you see this on an oven, this is like the one that we just tested here. Gas comes in through here, and when we get the right voltage here, gas comes out through this, what we call an orifice. Okay? This one here, that's a dual gas valve. And remember, the reason why they say dual, you'll usually find this on the higher end gas stoves or the self-cleaning gas stoves, where they actually have 2 burners in there, one in the oven at the bottom and one at the top for broiling. A stove that only has one at the bottom, usually the drawer on the bottom is how they broil, okay? But if you look here, there's 2 terminals and gas comes out this side, but you see here we got another orifice. You can barely see it, but there's 2 more terminals on this side, and what it is cut this in half. And this basically looks like this, right? And so what it is, it's actually 2 valves, one here and another one upside down. So if I put power to this one, the gas is going to shoot to the bake burner for example. If I turn on this one, it's going to go to the broil. Okay? They're going to have separate igniters, and instead of having 2 separate valves, they have 1 double valve for both burners. How do you check them? Well, first of all, if you could read it, it has the voltage and the amperage right on the valve. But if you learn how to test it, when you get that 3.3, 3.03, when you get right in that ballpark, they're all pretty much the same. Okay, so if you have to get down into the oven, that's how you would do it. All right, anybody got any questions on that? No? Okay.
Do you have that the gas valve?
No, because we don't have a self-cleaning gas oven, okay? Let's go to the surface assembly. Here's a surface burner. Not exactly like you see here, but this part here is the burner head. We call this the burner head. This is where the gas comes out. We see the flame when we're cooking. This right here, does anybody know what the name of this area is right here?
Orifice. What's that?
It's the orifice.
Venturi,
Oh, yeah.
okay? The orifice, if you look at the arrow's pointing here. The orifice is not on the burner. The orifice, where is the gas valve that was here? Where was the gas valve here?
It's on the,
Oh, it's on the phone. Okay. Here is the gas valve on the top of the stove. We got 4 of them here, controlling each burner. So this here goes inside the tip here. So the orifice is just this opening right here. Okay? This one here, if you were converting the stove from one gas to the other, you have to take this orifice off and replace it with the right orifice. And if it was natural, the opening is larger on a natural one than a LP one. So let me see something here. Now I have to look on the back of the stove. A lot of times on the back of the stove, they'll have a little bracket with 4 of these orifices on it, and they would have the replacement ones. The stove would come set for natural, and the LP ones would be screwed to a bracket on the back of the stove. So when you take a look at this valve here, when you turn it on and off, you're just twisting this here. If we look at this, I'm gonna color it in a little bit. This is inside the valve, okay? When I turn this shaft, right now, gas can't get out of the valve. And this piece right here is where gas is coming in, right here. When I rotate the valve, this opening lines up and allows gas to flow out of the orifice. Now that valve sits on a square tubing on the stove here. We call that a manifold. And so this is where the gas comes in from the customer's home, and it feeds into this valve through here, and it goes out. This is just like your sink water valve or your hose water valve outside your house. You just turn it, and the water comes out. You turn it, it closes. It's not anything magical. Really, they don't want you taking the valves themselves apart. You can replace this in a customer's home, and you can take it off of the manifold, but you want to make sure that if you look right here, you can see there's a gasket on the bottom of the valve here, and you can see the opening where the gas comes in. The screw comes in the bottom. So the gas comes in through here on the manifold, and you got to make sure that this gasket's here, and the old gasket's no longer there. Okay, so if you want to see that we got openings on the side here where the gas is coming in. The opening down here is where the screw holds it to the manifold, and this is where the gasket is so we don't leak. So if we unscrew it, we pull it out, pop a new one in. Make sure you turn the gas off to the stove first. But you don't want the old gasket to remain on the manifold, and you want to make sure that the new valve has this gasket here. So it goes in through these openings here, and goes into the valve and out, okay? So let's go back to this burner. So right here is the orifice. Some of those orifices are adjustable on the valve instead of replacement. If you look at this, this is an adjustable orifice. Inside the orifice right here, we have something called a spud. Spud actually has a purpose. It's usually a triangular piece, and when gas is shot out through this surface valve, it causes a spiraling motion of the gas. Okay? And when it comes out of here, we want it to do swirling. Why do we want it to swirl out of the orifice? Yes.
Better mix with the outside air?
Better mixing with the oxygen on the air shutter, very good. So we have an air shutter right here, which we can adjust. For natural gas, it closes the opening a little bit. For LP gas, we open it wide open. So the orifice shoots down through here. Right at the beginning of this valve, you can see it sort of pinched off. And that pinch off, the gas is going to shoot right down the middle. If this orifice and the venturi aren't lined up perfectly, like it's slightly crooked, the gas can shoot out the air where it's supposed to pull air in, gas can leak out. Or if it's not perfectly straight, you don't get a good mixture of air and gas, so you don't get a good blue flame. Okay, you get a yellow flame. So the gas shoots out the center, and as it shoots out, it's pulling air in with it. It's mixing it up here and coming out here. So we have an air shutter here, but the burner head, we call it secondary air. Well, I spelled it wrong, but secondary air. Okay? And the gas mixes with the air in the air shutter the first time, swirls through the venturi, and as it comes out the burner head, yes, Mike? Something funny happened? I missed it. Okay. So as it comes out of the burner head, it's got to be blue. If you get a yellow flame, you're going to get black stuff on your pot, which is like soot and carbon, and that's not good. Okay? So let me see one more picture here. Here's a side view of that burner head. Okay? So on the side of the burner head, we have to have a way to ignite it. There's a spark module with an igniter, and the igniter will be located right here, or a pilot flame. And as gas is coming out this igniter or this pilot flame is too far away from the gas. So we have these holes here on the side of the burner. We shoot the gas down through something called a flash tube. The flame lights it, it runs back and it climbs up these holes and lights our burner. Okay? Those holes are located here on the side of the burner. Can you see those little holes there?
Yeah.
See those little holes there? The biggest thing that happens is when people are cooking with a lot of grease, these holes get filled up with grease and it won't shoot the gas down the flash tube and the burner won't light. Can you see those holes? You see that? I'll show the camera. Can you see the holes in the burner right here? Got it? Okay. So if they're covered with grease, it's not going to light. You see the guy's taking either like a toothpick or a needle and he's poking the holes. One of the worst things that people can do is they want to clean these. So they take them off their stove and they throw them in the sink and they soak them in the sink. And the cleaning agent and the detergent and the water actually cause them to rust inside. These are cheap metal. They're not 100% aluminum. So they rust inside, it's going to cause all kinds of air and gas flow problems, and we're not going to have proper burning. So they recommend you clean them on the outside, you rinse them off and dry them out right away, but don't soak them in soapy water and clean them out from the inside out. It's no good. Okay? Let's take a look at the spark ignition system on here. I didn't have a spark igniter. But if we look at this stove, we have two igniters, one right here and one right here. This igniter lights both the left and the right. If I turn on one, they both come on. This does not have a way of separating the front from the rear or the left from the right. And we use something called a spark module to do that. The spark module has two wires coming off of it, which is the left and the right igniter. One of them is neutral, and the other one's power coming in. Now how does that do it? If you look on the front of these valves, we have these little square boxes. Those are switches. If you look at this harness here, these four switches come together. If one fails, you replace the whole assembly. These switches are wired how?
In series?
Well, let's look at the diagram. Here they are right here. How are they wired?
Parallel.
They're parallel. If they were in series and you only closed one, nothing will happen because the others would be open.
Yep.
So they all have to be parallel. And as you can see, power will come in through here, through one of those switches, and go directly to my spark module, and the other side's neutral. It'll start sparking. Now, when you light it, you have to turn it to the light position to send power there. Once it's lit, you turn it to the high, it's no longer sparking. Yes?
No, I was just wondering because, I mean, it looks like it's in series from the wiring itself.
Well,
Okay.
this switch is in series with the module,
Yeah, that-
but how are the four switches as you see them?
In parallel.
They're
definitely.
parallel to each other.
But it looks like it's in series in the wiring itself. I mean,
No, because if you look, we got a black and a red.
Oh,
So if I close this one, it goes right to black. If I close this one, it goes right to black. Yeah, it goes through the switch here, but it's not going through a contact this way. What's the biggest problem you have with these switches? Anybody know?
If one is bad, everything is bad.
Well, one bad, you have to place the whole assembly. But the biggest problem is people want to clean their stove, and they go here to the front control panel, and they take the knobs off, and they take this real wet sponge with soapy water. It gets down inside these switches, and you get water in the switch. It doesn't blow up. The switch just keeps sending power to the spark module. It's just sparking all the time. Now you can do one of two things. You can take a hair dryer and dry it out, but now you have that soapy water that's inside, could cause a problem with the switch in the future. Or you just replace it or tell them, hey, if you wait long enough, it'll dry, it'll stop sparking. So that's the biggest thing that happens with these. If you rotate it, you get it to the right position, you can go to the end of the wiring, or you can stick your meter right into one end and you check continuity if the switch is closing or opening. One thing you could do also is go to the spark module and put your meter here on these two terminals, and that would be these two terminals right here, and you're gonna check for 110 volts. If you have 110 volts and neither one of them are sparking, what's bad?
Yeah.
This. What if, let's say I send power here, right? These are my two igniters. Let's say the left and the right here, this and this. Let's say the left one is sparking, but the right one's not. What do? You change the module or you change the igniter?
Neither.
I changed the module, stop module.
Well, I don't change anything until I test it out. So if you look, these are the two igniters here. What can we do? If this one's working, this one's not, what if I pulled this one out that wasn't working and plugged it in over here with the one that was working? If it starts working now, what happened? This is bad.
Change.
So if I switch the wires, and let's say this one is sparking, but this one wasn't, I unplug this one and plug it into the other side, now it starts sparking, the igniter's good, right? The module's bad. Okay? So, what could happen to an igniter? What could cause an igniter to fail? Anybody got an idea? No?
That,
It could be crooked, because I'm looking at it like a spark plug, you know? How you have to, like, get the right
Gap?
like, gap between it. I'm thinking maybe something happened and it got bent.
So the igniter is ceramic, and it's got a wire here, and it's got just a little metal tip on the end, and he's right, there's a piece of metal here, and when you light it, all my markers are over here. When you light it, the spark has to jump from here to here, and the gas is gonna get lit. But if it's too far away from the metal, it's not gonna spark. But what happens a lot is, this is ceramic. If you look at my drawing, what does it look like? It's broken, right? If the ceramic gets cracked, this is an insulator to keep the spark jumping from the tip. If anywhere down here it's cracked, the spark can jump out of here. I've had one where the wire going to it was up against a sharp edge of the stove. So one side was sparking, the other side wasn't, because it was grounding out here and not letting the tip. Remember, when it jumps from the tip to the metal here, that's got resistance as the spark's jumping through the air. So if the wire's cut and real close to the metal, the spark will jump here because the distance is shorter than the tip, and we have no spark. Okay, so I found them where they were cut, and the spark was jumping here. I just put a little electrical tape around it. It was done.
Now,
But that's as long as the tape's not near any flame. Yes, sir.
if someone was touching it while that was happening, would it get a little jump?
Yes,
I'm
it'll
just
make
saying,
you
as
jump.
like when you're
Yeah.
going through your notes and you get to the, you're looking at your sheet and it says, "Oh, I'm getting shocked every time I turn it on," or something like that.
No, they would not get shocked because what happens if you look at this symbol right here, this symbol's grounded.
Mhm.
So when this jumps from here to here, it's using ground to complete the
I
circuit.
know. I'm saying if the ceramic though is broken and it's
No.
no.
No, because it doesn't matter where the spark goes. If you look at this spark module, if you look right here and right here, you see this like little brass ring around the edge of the module? That's actually grounding out this module. So when it's screwed on either one of these to the frame of the machine, that's completing the circuit from here all the way back. So it doesn't matter where that spark is. Now, even if this is not grounded, the stove, if it has a proper ground on the power cord, that spark will go through the ground in the power cord. It will not shock the customer as long as it's there.
Okay.
Okay? Now, on some more higher end units, it's very important. Here you have the burner head with the gas flame, and they have a spark igniter right here. And the spark jumps right to the head of the burner, and the flame will go through here. What the flame does on those models, unlike this one here, when you light it, you put it to what we call the light position, you start hearing it sparking. Once the flame lights, you turn it to the high position or medium or low, whatever size you want your flame, the switch opens and stops sending power to stop sparking. But on some of these high-end units, you're sending power to a control board. And that board will send power to this igniter, and the igniter's got to jump across. It's very important that that igniter goes across the actual opening of the burner. It has to be right where the gas is coming out. If it's slightly off and the flame lights, it will continue sparking while they're cooking. It'll never stop. But what happens is when the flame lights and it's properly lined up, the flame actually grounds the ignition out and the board stops sparking. Now, if a customer turns on another burner, it'll start sparking again until the next flame grounds it out. Okay, so if you get one that has like an actual control board and not one of these little modules like this, that flame is important. Okay? We had a lot of the GE ones where the burner was. We have a simmer flame right here that has a very, very low flame coming out. And that stove, I've run across 2 or 3 of them now made by GE. They get grease in between the 2 pieces of the burner, and the simmer flame is what grounds out the spark. Or it causes a problem with the lighting because the gas is not shooting out there and the spark igniter's not hitting it. We've had to take them off and had to scrape the grease. The grease actually turns like to a black tar. At one point we just replaced all the burner heads, everything was working just fine. But you see it sparking. I was with Marvin on that call, by the way, that we saw that the gas pressure was good, the spark's working. You could light the burner with a match or a lighter, but it wouldn't light with the igniter. And the spark was jumping where you want it to jump. But the simmer flame, this one doesn't have it. This is the cheaper burners. Simmer flame was right in the middle here. If that's not good, it's not working. We don't have one of those here. But that's important. So send power here. If both of them are not working and you have 110 here, the module's back. Okay? So you have to check those things out. It's very simple to check those out. Now, simmer. Where did I put my valve? Oh, here. The gas valve. We talked about the gas valve. On some of these valves, I'm going to pass it around. You probably can't really see it, but the shaft of this valve is open. Okay? It's not shown in here, but this is hollow, and it goes all the way down to here, and you find a little screw right here. That's a simmer flame. And what that is you take and you turn the gas burner on, and you put it to the lowest position, and you adjust that screw so that your flame is just barely coming off the tip like that. Flame should be about 3/4 of an inch to almost an inch in length. Should be like this. It should be 99% or so blue with a little yellow or whitish tip. If it's too yellow, you don't have enough oxygen and too much gas. It's just like your oxyacetylene torches. If you have too much gas and not enough oxygen, it's not gonna be blue, and you're gonna have black soot everywhere.
Yeah.
Okay, so this simmer is only adjusted when the unit is set to its lowest flame height. And what simmer is like they're cooking, but now they're done cooking, but they want to sort of keep it warm or just keep it hot. Almost like when you go to a party and they have those aluminum pans and they have that sterno can underneath. They don't want to cook the food, they just want to keep the food hot. So that's what the simmer flame is. Okay? So that's how we take a look at that. So we did the oven valve. Let's take a look at the regulator. I didn't get a picture of the regulator, but I have one here. We talked about the regulators on the gas dryer. Gas comes in one side, it comes out two different openings on this regulator. One goes directly to the oven safety valve, which we had on the table here, and the other one runs up top to the manifold here. Okay? This is where the burner cap is. Some of these caps, you take them off and you flip the whole cap over when you're going from one gas to the other. This particular one has a little plastic piece. Just a little piece of plastic. Okay? It's like a little cap. All right? This goes inside the regulator. When the cap is open here and goes over the spring like that, what is that, natural or LP?
LP.
Natural. The LP, remember the dryer had that we did that dryer lecture, had that pin that pushed down on the spring? When you flip the cap over and you put the part in here that pushes down on the spring, that's for LP. So when a customer buys a stove or a dryer, it's coming set up for natural. You have to take the cover off here, flip the cap, okay? In this case, you're not flipping the cap, you're flipping the plastic piece. That snaps into the cap. It has little clips here and snaps right in. You twist and turn it. So you twist and turn it, and then when you screw this in, it pushes down on the spring. And now it's set for LP. So you have to do this. You have to go to every burner, either adjust or replace the orifice, and do what to the air shutter? Open it wide up. If you look at this oven safety valve here, this is an adjustable orifice. When you come for natural, the orifice is going to be all the way up. We want to tighten it down. It's very important when you tighten this orifice not to over tighten on that spud. Let's go back to that picture here. So what it is you're tightening. If you look at these jagged lines here, that's just threads. When you screw it down, you don't want to tighten it. You'll damage this little spiral spud in here, and then you won't have the gas swirling out like you're supposed to. You'll damage the valve. So what you do is you turn it till it stops turning, and that's it. Sometimes you might have to back it off like 1/8 of a turn or 1/4 of a turn. You're done. You want to light it up? Take a look at your flame. Now, the oven flame is not like the top of a stove. When you put the stove on and you put it on high, you have a big flame. When you put it on low, the flame gets smaller. The oven flame is always the same size, whether I put it to 500 degrees or to 150 degrees. The flame is only coming off the tip here about 3/4 of an inch to an inch. and then you have a shield here, which the flame rises up. The only difference from 150 to 500 degrees is it just stays on until that thermostat says it's hot and shuts it off. So this flame in your oven doesn't change size depending on the temperature that you set it. It's either on or off.
So you're
Okay.
gonna get a lot more cycles at a lower temperature than you are at a higher temperature.
Well, yeah, I guess you would say that. It would shut off a lot faster than that, so, and then the temperature dropping is the same either way. So again, it's very important you look at this voltage and amperage on this valve when you're working on them, so you know how much voltage it takes to open it. These numbers here are important. When you check voltage across this valve, it tells you right on the valve, I need 3 volts, 3.03 to 3.3 volts, or 3.3 to 3.6 amps. When we check amperage, we clamp around only one wire. If you clamp around 2 wires or more, you're not gonna get a reading. What happens is electricity flows through one wire one way, flows through another wire the other way. When we check amperage around a wire like this, what it's measuring is as electricity flows through the wire, it creates a magnetic field in the air. Okay, the more electricity, the bigger the magnet.
Yeah.
But if you put 2 wires going the opposite way, the 2 magnetic fields cancel each other out, the meter can't read it. So you can't go across a power cord like this and measure amperage, it just don't work. You have to go down where the wires in the oven break up to a single wire, and that's how you do it. Okay? Anybody any questions on these components? Okay, when you guys are doing these gas stoves, I want you to do these amperage tests and these voltage tests on these valves. Okay? Look for these voltages. Make sure you have a better meter than that one, because that one didn't read the right voltage. Could be reading the right voltage. What if my outlet wasn't proper?
But you're getting the proper amperage reading.
Got the proper amperage reading. I should have the proper voltage, but if I don't, shouldn't I check the voltage in the wall?
Yes.
Even though the amperage is good, but not the voltage? I need to check the wall first to see if my wall is proper.
But with a different meter? Or
Yes.
Okay.
Well, I'd use both meters. I wanna know my meter's good, because otherwise I'm gonna throw it in the trash. Because it's not reading the right voltage, it's no good to me, right?
Yeah.
Alright, so that's how you test these components out. I'm not lighting them up today or whatever, we'll do that another day. Any questions on these components? No? Okay guys, go back to do your shop works.